Hello. Well, what I'm going to look at here is that there's one of the exercises you have to do. I think in actual fact, although the screen in front of you, you can see 1 and 2, it's actually 3 and 4 in the list of exercises that you're doing. And you shouldn't necessarily have had too much trouble with the first one, the algorithm for assigning the correct number of days. There were a few things in it that you needed to be aware of. For instance, here what we've got is that this is pseudocode or PDL, and so as a consequence there are things like OR which you'll need to learn how to translate. Now, just in case you've not picked up on this, on the Blackboard side, when you go into learning materials, you normally go into semester 1, but there's this document here, pseudocode to ActionScript, and it will help you translate between your pseudocode and ActionScript. I'll just log out of that and close that window because I don't need it. So let me just show you what that document looks like. It looks like this, and it will help you look at what it says is HTTLAP, in other words, how to think like a programmer, and the language we're writing in AS3. At the moment I've got it focused on how to write a function, so I won't move, but further up in that document it explains how to translate an OR statement. It's actually 2 vertical bars, and then the only other problem you have is that with an if statement all of those things have to go in parents, that's the round brackets, and then at the end of the if there's a brace, and there's a brace. But I would imagine you've managed to figure out that part for yourselves by again looking at that document. So here I've implemented that. I've set up a variable for month. I've set up a variable for how many days in the month, setting it initially to be 0 so they can assign different values to it. And I've made up a variable called is leap year, which I've just happened to say is true, that it is a leap year. And I can play around with these values by changing that to false and changing that to a different month number to test whether or not it prints out with my trace statement how many days are in the month. So here it will print out days in the month, and whatever that variable equals, which will equal 31 or 28 or 29 or 30, depending. So I'm assuming that you've got that far and you've got that to work. So at the moment then, I'm using this variable called is leap year, which I've just made a boolean that is true. But if we look on to the next part, which, as I say, on the exercises, it's number 4, not number 2. It says extend your solution by designing and writing a small algorithm that determines whether the year is a leap year. You'll need to declare a variable called year and assign it a different number of values to test your algorithm, in other words, test whether it's right. And then there's this explanation of what that algorithm is, whether it's a century year and it's divisible by 4, or if it's not a century year, in which case it's, blah blah. It's not complicated, but there's a few different parts to it. Now, because there's a few different parts to it, it seems to me a great time to use a function. So instead of having a variable here or replacing that variable with if it's a century year and if it's divided by 5, instead what I'm going to do is replace that Boolean variable with a function. I'm going to write a function that I'm also going to call is leap year. And since this is a Boolean variable, in other words, knowing whether is a leap year is true or false is useful, my function, I'm going to make it return a Boolean value. In other words, I'm going to make the function return either true or false. So my logic is that if I write this function called is leap year, pass as an argument to that function the year in question, it can do all of the working out of whether it's a leap year and just return to me true or false. So that's the plan. In other words, I'm using a function to take a value, do some working out, but hide that working out inside the function and just return some answer, in this case a Boolean. So let's do it bit by bit. I'm going to get rid of this variable is leap year because I'm not going to use that anymore, and I'm going to replace it with a variable called year because that's what I was told to do in the problem, and it's just going to be an integer. There's no fractional part to the year, and I'll set it to some value to begin with, 2000. Okay, now I'm going to have to write a function that I'm going to call is leap year. So to write a function, what I need to do is after the brace for this function, but still inside the brace, so it's inside the class. So I'm going to put my cursor there, scroll down to make sure I've got the right brace. So that's the end brace for the public function main. So after that, but still before this brace, which is the closing brace for the class, I'm going to write my function. Now, to remind you, on this particular part, it explains how we write a function. So this part here, from there to the left, is how to do it in how to think like a programmer speak, in other words, pseudocode. And this part is how to do it in AS3. Now let me translate this. Access modifier. That's, and it explains what that is here. It explains in detail. I'll let you read that. But it's whether or not it's public, something called internal, protected, or private. I won't explain what those are at the moment. You can read that and we'll cover it in more depth later. But the basic rule is you want to make it as narrow in scope as possible, as narrow access as possible. And the most narrow is private, so I'm going to start with private. So access module will be private. Then there's the word function. Then the function identifier, in other words, the name of it. And then whatever the parameter is, colon, and whatever the type is. And then, this is an important part, colon, and whatever the return type is. Then a brace and an end brace, and all of the stuff you're going to do, and finally some return. So let's translate that into actual practice. So where I am now, I'm going to do the access modifier, private. I'm going to write the word function. I'm going to call my function is leap year. It's going to take a year, in other words a variable, and this variable, I could call that anything, but I might as well call it year, and that is of type int, and that's the only parameter it'll have, but it's going to return a value, so colon, and the value it will return is a boolean. And then I open the brace to start my function, and when I hit enter, Flash will automatically put in the end brace for me. So now I've got to do all of this working out of whether something is a leap year or not, and on the exercises it explains that here. And I've taken that and I've pasted it as a comment at the bottom so I can kind of understand it a bit more clearly. And the way I see it is a non-century year is a leap year if it's divisible by 4. A century year is a leap year if it's also divisible by 400. So it seems to me I need to find a way of going if, and then obviously open close brackets, because that will be my condition. And I'm going to do this first of all so as not to make a mistake. If, I've got to come back and write my condition, open the brace, and it will close the brace. So in there is my condition. Is it a century year? So year is my variable that I'm dealing with. Well, there's a really good function, a really good operator rather, in most programming languages that you maybe not have come across before, but it's called modulus. And what the modulus or modulo function does, or operator does, is it divides something and tells you if there's any left over. So if I say 2 modulo 2, 2 goes into 2 once with no leftovers, so the leftover is 0, and modulus tells us what the leftover is. So 2 modulo 2, there's a leftover of 0, in other words it goes in exactly with no remainder, whereas 3 modulo 2, it goes in once but with a leftover of 1. So you can see how if I do the modulo using 2, it tells me even numbers, because any even number 2 divides into with no remainder, and any odd numbers it divides in but there is a remainder. So on that basis, a century year is any year which when I divide it by 100 won't have any remainder. At least I think that's the case. If you find that's not the case, then tell me please, because my maths is dreadful. But that's the basis on which I'm going to work. So what's the modulo operator? Well, if you look in that translation document, I think it tells you there, and it's I would have never guessed it, but it's the percentage mark. So if I say year modulo 100 equals 0, then what I've done is divide 100 into year. Because it's the modulo, it gives me the remainder, and if the remainder is equivalent to equals 0, it means it must be a century year. So this in here means it is a century year. So I'm going to comment that. Is century year. So if I'm in here, it's a century year. Now my rule says a century year is only a leap year if it's divisible by 400. So I guess that means if when I divide by 400, there's no leftover. So I could write this: if year modulo, what was it, 400, is equivalent to 0, in other words, there's no leftover, then start an open brace, and it is a year, so what I want to do is return true. Okay, so the thing is if it's not a century year, it only has to be divisible by 4, so this is the part that says is a century year. Actually, I'll comment this as well at the same time. Is divisible by 400. And what I wanted to deal with now is things that aren't a century year. So this is the line that says it is a century year, and that's the end of that if. So if I put an else there, then this is what happens if it's not a century year. So I'm going to comment that so I don't forget. Not a century year. So this is what happens if it's not a century year. Well, a non-century year is a leap year if it's divisible by 4. So let's do that. If year modulo 4 has no leftover, in other words, if it's equivalent to 0, then I return true. Okay. So I'm going to return true in that case. I'm going to return true in that case, which means that if I get to the end and I've not already returned, it's not gone into there, so it's not a century, it's not passed any of those tests. So if it gets to here, then I could just return false, because it mustn't have already returned, because what happens is the program comes in here, if it goes into there, it goes to line 36 and does that. If it goes into there, it returns. In other words, it jumps straight back out where it came from. It doesn't carry on to anything else. Okay, it just returns. So it will only have got to this point if it's not returned previously from somewhere. Does that make sense? So let's try this out. Is leap year then is my function. So let me go back to the bit where I just said is leap year as a variable. And instead of that variable, now what I've got to put in there is my function. And my function is called is leap year. Now, is leap year is inside this class that we've got. And anything inside this class that belongs to this class is part of this class. And to make life easier, we can actually prefix anything that's to do with this class with the word this. And notice what happens. If I write this dot, then I should end up with a little pop-up box, and I'm not going to. This, what did I call it, is leap year, open brackets, and inside there I've got to call my function passing in the variable called year. Now it should have hinted at me there and it didn't hint at me, so that might mean I've made a mistake somewhere, but that's okay. I'll just save that. Now, I think what I might do is, just having saved it, I'm just going to cut that and try once more. Dot. No, it didn't do anything, so I'll just paste it back in again, and we'll test it, and if we've got an error I'll figure out why it wasn't reminding me. I did call it is leap year and it is returning boolean. So sorry, I'm muttering. So in this if statement then, whereas before in there I had my variable is leap year, now I've got my function this is leap year, and I'm passing in year, which is the variable that I declared up here. So what should happen then is by calling that function passing in year, it'll come to here, and this function will return true or false. So let's see what happens. Let's give it some values that it should say it's a leap year. In other words, it should say 29 days. If I say it's month 2, in other words February, and it's year 2000, I think that was one of the things that it said. So 2000 was a leap year. So let's see if that works. So I'm going to press Control Enter, and let's see what happens. Press Control Enter and nothing seemed to happen. So it's because I've tried to kind of jump ahead, and I've not opened my FLA file, and it's the FLA file I've got to start. So I'll press Control Enter, and it's starting this movie, and it says checking how many days are in the month. Days in month 29. In other words, it is a leap year. So 2000 that I'd got. I just clicked on the X. And again, 2000 February. It is a leap year. So what did it say? The other one was, it said 1900 is a century year, but it's not divisible by 400. So let's change that to 1900, and instead of saying there are 29 days, it should only say there are 28 days. So I'll save that, Control Enter, and it correctly says 28 days. Well, it so happens that 2004 was also a leap year, so I'll try it with 2004, save that, and Control Enter, and it's come out correctly with a leap year. Obviously, there's no need for me in this particular test to try a different month, because it's only in February that a leap year adds on an extra day. So it still didn't explain to me why that didn't pop up with this, but nonetheless, just believe me that when you say this dot, it refers to functions that are inside this class. And normally, honestly, if I go, now it's decided to play, there it is, look. There's my function. It's expecting a parameter called year, and it will return a boolean, just as my declaration said. And normally you can click on that, pass in your year. Remember to close the parens, because the outside parens matches that one. And that's it. It's a really good example of when a function can be useful, because instead of putting all of this logic here, in here, it hides that kind of complexity, and it makes it look a lot simpler. Right, as a small addendum, I'm going to just show you a slightly different reworking of that function. And it was actually the way I wrote the function the first time I wrote it, and then when I recorded it for you, I made it what I thought was slightly simpler, but when I've thought about it since, perhaps the version I wrote first is simpler, so I thought I'll give you both of them so that you can judge for yourselves. Right, the first thing I'll do, just so that there isn't a name clash, I don't have two things with the same name, is I'm just going to copy that part, and then I'm going to copy that and paste it in again here, and unrename this one. So this is just because I've got it twice. So just pressed completely the wrong key and moved down. On my Mac, if I press home and end, it goes to the top and the bottom instead of to the end of the line. It always confuses me. Okay, so in here I'm going to write this different version. So the way I really would start, I did the other one just by writing code, but I would normally start like this. If it's a century year, then this is what I'm going to do if it's a century year. I'm going to return whether it's divisible by 400, with no remainder, of course. I'm going to use that exactly the same, the modulus thing. And then what we've got here is the else. In other words, it's not a century year. I'll put in else it's not a century year. code that goes in there, and that will be return, excuse the spelling mistake, can't be bothered to change it, whether it's divisible by 4 with no remainder, and then that's the end if. Okay, so that's what I'm going to code. So if it's a century year, so let me put that first of all here. So if, then my condition, then the open brace, and my condition is the same as it was before. It's year modulo 100, and if that equals 0, in other words there's no remainder, and if that's true, then we're in here. Now I'll put the end braces in, so it's just my structure is correct in the first place. So that's the else part, and then it starts there, and then instead of the end if, it's the brace. So I've got the basic structure that if it's a year it'll do this code, a century year it'll do this code, else it'll do this code. Now in the previous version, inside here I had an if statement that worked out whether it was true or false. In fact, you can see it below on line 46. It checked whether if the year was moduloed by 400 equals 0. Well, if it is, in other words, if that evaluates to true, then it returns true. Well, in a way, we could just return that expression, because that expression, year modulo 400 equals 0, is either true or false. And if we just return the answer to that, it will return true or false. In other words, was it a leap year or wasn't it? So I can simply write return open parens year modulo 400 equals 0. Close parens, semicolon, because it's the end of a line. And that does exactly the same as where we have on line 46 below the if statement that returns true. And that's exactly the same here. Else it's not a century year, so the sum is not that it's divisible by 400, but that it's divisible by 4. So we just return year modulo 4 equals 0, because there's no remainder, and semicolon because it's the end of the line, and return whether that's true or false. So we don't need, we've saved a certain amount of code. We don't need the two if statements, and we don't need the return false at the end. We don't need these if statements and return true. It's become a slightly simpler looking algorithm, and maybe that's easy for you to understand. If it's a century year, just return whether or not it's divisible by 400. Else it's not a century year, so just return whether or not it's divisible by 4. And maybe that becomes a slightly simpler algorithm for you to understand. Okay, over and out. Hope that's helpful.